Right. So I'll be sharing your screen now. Let me know if that is visible. Yeah, is it visible?
Yes, sir.
Right. So Navneet, let me know a little bit about you. You are studying in CBSE school,
Yes, sir.
right? So so are you planning to write board and apart from that any competitive exam like JEE or something else?
No, sir.
No, only board itself.
Yeah.
All right. Fine, Navneet. So you're this year you are starting 11th grade, right?
Yes, sir.
All right. So let me start with the lesson. Yeah, is it visible what I'm writing on the board?
Yes, sir.
All right, now. Fine. So Navneet, we will be discussing one concept of the first lesson, which is dimensional analysis.
Okay, sir.
Have you come across this anytime? No, right, fine. So before we go to this concept, dimensional analysis, let us see one important concept that relates to dimensional analysis, right? So do you know what are physical quantities? Physical
Yes, sir.
quantities. Yeah, could you tell me in layman terms what is physical quantities? You can keep your video on so that we can
One
interact.
second, 1 second, sir. 1 second.
All right. Yeah, ma. Do you have any idea about physical quantity?
Like,
All right, not an issue. See, physical quantities are those quantities that are measurable. Simply, we can
okay.
say any measurable quantities.
Mm.
If a quantity is measurable, they are physical quantities. Some quantity,
Okay.
for example, let me give you an example for this. Like you can measure the length, right? Length of an
Yeah.
object, length of something. So that is a physical quantity. Length is a physical. You can measure time also, right? You
Yeah.
can measure mass as well. So these are all physical quantities which are measurable. There are some there are some quantities which are not measurable. For example, let me give you examples of not measurable quantities. Like you are happy today. If I say, can you measure your
Mm.
happiness?
No.
No. If I tell, like for example, I'm feeling good today. Can you measure how much
Mm.
good you are feeling?
No.
No. You are bored today. So these are all quantities, but they are not measurable. They are feelings just. They are not measurable. So these are not
No.
physical quantities. So if the physical quantities are those which are simply measurable quantities.
Okay.
All right. So this is the first thing that you must know. The second thing is that these physical quantities are basically two types. If I go for types of these physical quantities, I'm writing short form PQ that represents physical quantities. All right. So types of physical quantities, if I see, there are two types basically. The first one is fundamental quantity.
Okay.
Fundamental quantities. Okay. Fundamental quantities. So there are 7 fundamental quantities. There are 7 fundamental quantities.
Fundamental.
And the second type is derived quantity, which are taken from that 7 fundamental quantities. They are just
Okay.
like the base. These are called the base quantities, also called as base quantities, because
Mm.
remaining all physical quantities are taken from these seven fundamental quantities. Okay,
Okay.
that's why These are the fundamentals. Remaining are all called derived. Derived means taken from them.
Yeah.
All right. So what are those 7 fundamental quantities? Let us say the first fundamental quantity is length. Okay. We denote length by capital L. Okay. Capital L, if I write in the brackets like this represents the dimension of L. Dimension of length. Okay. In square bracket, if I write, that is the dimension of length. Second thing is mass. Mass. Okay. I'll take capital M. And if I write in square bracket, that becomes the dimension of mass. All right. So third one is time. Time dimensions. If I take, I'll take capital T. All right. So the fourth one is there are total 7 fundamental quantities. So first one length, mass, third one time. The fourth one is thermodynamic temperature. Thermodynamic temperature. We denote it with capital K and again keep it square bracket. That is the dimension of temperature, thermodynamic temperature. Fifth one, if you see, fifth one is luminous intensity. It is about light, how sharp, how bright the light is. Intensity. It is measured in candela. So we use capital C and small d in bracket. So you might be thinking, what are these two? These two are different. You know about this and this. This also you might be knowing about temperature, but this is very rarely used. But in second year, in your 12th grade, you will come to know the usage of this in light lesson. All right, optics lesson basically. So the sixth one is thermodynamic temperature, fourth one, fifth one luminous intensity, and the sixth one is current, electric current.
Okay.
So electric current is measured in amperes. So capital A is its dimension. So the seventh one is B, amount of substance.
Okay.
Amount of substance is measured in moles. So we use capital MOL, N in brackets. So what are these? Whatever I have kept in bracket, those are the dimensions of the respective thing. L for length, M for mass, T for time, K for thermodynamic temperature. Why we use K here? Because the units are Kelvin. Okay, and luminous intensity is CD, CD for candela. Okay, electric current A is for ampere. And amount of substance, MOL, it is MOLE, mole. So in short form, we use capital MOL, right? So these are the 7 fundamental quantities and their dimensions. All right. Now remaining, if you see the second type, if I speak about, it is derived quantities. Derived quantities. As I said you, derived quantities are those which are taken from those 7 fundamental quantities only. All right. So let us see some other some examples of derived quantities. For example, if I take area. Area is simply length into breadth, right? One dimension of length and another dimension is breadth. See, the breadth we call as such, but both are the lengths only, no? They are measured in meters only, right? They are same dimensions. It is also length and it's also a breadth. But because of the other direction, we name it as breadth. Length and breadth. Both are length only, basically, right? The name is given to make it different from this length. Length and length has same name, but we make horizontally length bigger one, the smaller one breadth we call. But both are measured with the same unit, no? The distance, how far it is. So if you see the dimensions of area, the length are having dimension L in square bracket. And the dimension of breadth are length only. Again, they are in square bracket. So double L. So we take L square is the dimension of area. Dimension of area is L square. Now, did you get an idea of how a dimension is made?
Yes, sir.
Right. Similarly, let me take another example of, say, volume. Volume, it is length. Do you know what is the formula of calculating volume?
Length into breadth into height.
Length into
Breadth into height.
breadth into height. See, basically these three are lengths only. One is in this direction, the other is this direction, and the third one is the height one, right? Length, breadth, and height. These are all same dimensions. So we say L in the square bracket, L in the square bracket, capital L in the square bracket. So the dimensions of volume become what?
L cube.
L cube. Okay. Now you have to tell me, I will give you the formula of one physical. See, these are all derived quantities. This area is derived. Why you call derived? Derived means taken from something. See, length is a fundamental. Area takes two lengths, means two fundamental quantities of length. Volume has taken three fundamental quantities of length, right? So that's why volume is also derived quantity. I'll take another example. Now you have to tell me the dimension of that physical quantity. So let us say the physical quantity I have taken, a derived physical quantity, which is, say, speed. Speed is nothing but distance traveled by the body. Can you tell me the formula of speed?
Distance by time.
Distance by time. Very good. Now tell me, distance is what kind of dimension distance has?
L.
L. Very good. What about time?
T.
Capital T in square bracket. So the dimensions of speed become, tell me now, dimensions of speed are L. This T I will take up. So it becomes what? T power
-1. -1.
Very good. Fantastic. -1. Both in square bracket like this. Done. Have you understood how to write the dimensions of a physical quantity?
Yes, sir.
All right, very good. Now I will give you one more physical quantity. You have to make the dimensions and let me know what it is. Okay. So say acceleration. Acceleration formula, have you idea about that? Do you have idea about that? Acceleration.
Velocity by time.
Velocity by time. Fantastic. Velocity by time. Now, could you, write the dimensions of velocity?
LT -1.
Very good. LT -1. What about T? Downtime.
T.
It is T only. Now tell me what is the total acceleration dimensions?
LT -2.
Yeah, it is LT power -2. Now you will be able to write dimensions of physical quantities. I hope so. Will you try one more?
Okay, sir.
Yeah. Let us say force. Force formula. Do you have idea about what is the formula of force?
Mass
From
into
Newton's.
acceleration.
Very good. Fantastic. Mass into acceleration. Right. Now write the dimensions of force. Try, because acceleration you already did.
M LT -2.
Fantastic job. That is the acceleration. That is the fourth dimensions, right? Mass times acceleration. Right. Now, one more. Okay, will you try one more?
Okay, sir.
Say pressure. Do you have idea of the formula of pressure?
Force by area.
Fantastic. It is force by area. Now, can you write the dimensions of pressure? You have already the dimensions of force. You have to take the dimension of area now.
T minus 2 I L square.
Tell me M. M will come.
MLT minus 2 by L square.
Do it. Do it in your mind and tell me final one.
M L power minus 1 T power minus 2.
Fantastic. Very good. M L power minus 1 T power minus 2. Very good. Right. So that's how. See, tell me one thing. What you have observed to write the dimensions of any physical quantity. What you must be knowing.
Sir, can you repeat?
Yeah, I'm asking you to write the dimensions of a physical quantity, say pressure, to write its dimensions. What you must know before that?
The formula.
Very good. You must know the equation in which this fits. And also, this, whatever the equation right hand side you have, you must also know the dimensions of those quantities so that you can plug in and get the dimensions.
Okay, sir.
Right. So that is what the dimensions are. So if you see the dimensional analysis, it has some advantages and disadvantages as well. But having this
Okay.
dimension analysis is useful, but it is to some extent, it has some applications. And it has some negatives also. We cannot apply in so many scenarios. In some fixed scenarios, we can apply. Okay, before we go to the applications part, you try one more example to write its dimensions. All right. Could you try with energy? You have any formula? Do you have in your mind any formula related to energy? It could be any type of energy.
No, sir.
Okay, fine. Now tell me, do you know some types of energies? Can you tell me some types
Kinetic
of energies?
energy,
Kinetic
potential
energy.
energy.
Potential. Could you tell me the formula of kinetic energy?
I don't know.
Okay, what about potential? Okay, I'll give you some hint. Try to remember. Something like it is related to mass and velocity, kinetic energy. Any idea?
Sir,
Yeah.
mass. Is it MV?
MV.
M.
Yeah, no. For see, kinetic energy, if I speak about kinetic energy, it has mass and velocity. Potential energy has mass. See, potential energy has mass, gravity, and height.
Okay, so potential energy is mgh.
Very good. Any one energy is enough to write the dimensional formula because all the energies are energies only, right? So if I speak about potential energy, it is mgh. Very good. The formula is mgh. M is for mass. G is for what is G is for?
Acceleration due to gravity.
Fantastic. It is a type of acceleration only, right? Which is due to gravity.
Yes. I have a maths tuition right now. I'll have to leave in another 5 minutes.
All right then, not an issue.
Okay.
All right.
I think we can complete this potential energy and then Navneet can ask any question if he has, and then we can just, wrap up, right?
Okay, sir.
Yeah. Navneet, 2 minutes. We will finish this and
Okay,
then
sir.
we can wind up. All right. See, mass, G is acceleration, H is height. Now, try to write the dimensions of this mass, acceleration, and height.
M.
Yeah.
LT minus 2,
M LT
N
minus
and
2
LT minus 2 and
and one more L, right?
height L.
Yeah, combine together. Together, total. M as M only. L power
L power L square T
L
minus
square
2.
T power
minus
minus
2.
2. Fantastic. That is the dimensions of energy. Could be any energy.
Yeah.
It has the same dimensions. Right,
Okay.
Navneet. So you have any
Okay.
doubt on this so far? Whatever I have
No,
told
sir.
you.
No, sir.
Yeah. Fine, Madan. See you.
Okay, sir. Thank you, sir.
Welcome.